In today's session, we are going to take a look at a few questions based on trigonometry. Let us look at the first question. If 4 cos square x minus 3 is equal to 0, find the values of first angle x, cos of x plus 15, cos 3x plus sine 3x. So let us first find the value of angle x. So I know that this is an equation. So I can say 4 cos square x minus 3 is equal to 0, which means that 4 cos square x transposing the minus 3 to the other side, it becomes positive 3, and therefore cos square x is equal to 3 upon 4. Now taking square root on both sides, I get cos x is equal to square root of 3 by 4, which means cos x is equal to root 3 divided by 2. And now I should be able to find the value of cos x, of the angle x, because I know that which angle has a cos value of root 3 by 2. If I remember the trigonometric table correctly, cos 30 has a value of root 3 by 2. So if cos x is equal to cos 30, then it implies that x is equal to 30 degrees, right? So the value of angle x is basically 30 degrees. That's the answer to the first subpart. Now I need to find the value of, so now I am solving the B subpart. So the B subpart says find the value of cos of x plus 15. Now I know the value of x, the value of x is 30. That means that I can find the value of this expression. This is cos of 30 plus 15, which is basically cos 45. And I know the value of cos 45 is 1 by root 2. Now let me find the C subpart. In the C subpart, I need to find, so in the C subpart, I am supposed to find cos 3x plus sine 3x. I have already found the value of x, x is 30. So this becomes cos of 3 times 30 plus sine of 3 times 30. The value of x is 30. So this becomes cos 90 plus sine 90. And I know the value of cos 90 is 0 and sine 90 is 1. Therefore, the answer to this is 1. So this is how I found all the three subparts. I will just pause for a minute and let you take a look at the solution, and then we move on to our next question. Moving on to the next question. Let's solve this particular question. Given that 3 sine square A plus 4 cos square B is equal to 4. So A and B are two different angles, if you notice here. And it's given that tan square B is equal to 3. Find the value of angle A. So now let us note down the equations that are given to us. We know that 3 sine square A plus 4 times cos square B is equal to 4. And I also know that tan square B is equal to 3. Now, from these two equations, I am trying to see which equation should I use first. Of course, the first equation has one unknown angle A and the other unknown angle is B. So using the first equation might not be of great help. However, I can definitely think of using the second equation because it has only angle B. So I will say if tan square B is equal to 3, if tan square B is equal to 3, then I can say that the value of tan B is square root of 3. Now I'm trying to find, or I'm trying to remember that angle whose tan was equal to root 3. I know that it is tan 60. So tan B equals tan 60. So which implies that angle B should be equal to 60 degrees. So this is the value of angle B that I get. Now I know the value of angle B. I can substitute the value of angle B in the first equation. So saying substitute B as 60 degrees in the first equation, I get 3 sine square A plus 4 cos square B is equal to 4. Now the value of angle B is 60, so this becomes 3 sine square A plus 4 cos square 60 is equal to 4, which means 3 sine square A plus 4 times cos 60 is half, the whole square is equal to 4. So 3 sine square A plus 4 times 1 by 4 is equal to 4. Now 4 and 4 cancels, and when 4 and 4 cancels, I get a 1. So this becomes 3 sine square A plus 1 is equal to 4, which means 3 sine square A is equal to 3, and therefore sine square A is therefore equal to 3 divided by 3, which means sine square A should be equal to 1, and therefore taking square root on both sides, I get sine A is equal to 1. This implies, now I am trying to remember which value of A should have its sine value equal to 1. I remember that from the sine row, sine 90 is equal to 1, which means if sine A equals sine 90, then the value of angle A has to be 90 degrees. So this is how I solve this particular question. Let me again pause for a minute and let you take a look at the solutions. Again, from these two equations, I first found the value of angle B. So angle B was 60 degrees. That was based on tan B equal to root 3. And then I just substituted that value of angle B in the first equation. I found the trigonometric ratio cos 60, and then I found the value of sine A. So this is how I solved this particular question. Let me pause for a minute. Moving on to the next question. Let us now solve the following equations for finding angle A. Let's take a look at the first equation. So it says tan square 3A is equal to 3. Please note, I cannot take this 3 down to division on the other side because 3A is the complete angle. So taking square root on both sides, I get tan 3A is equal to root 3. Now I am trying to find that angle whose tan is equal to root 3. So I get tan 3A is equal to tan 60. And therefore comparing the angles, I get 3A is equal to 60 degrees. 3A equals 60, which means angle A is equal to 20 degrees. So this is how I find the value of angle A. Let's now try the second one. So I have 2 times tan square of A minus 5 is equal to 2. This 2 is in multiplication with tan square, so I can send it down to division on the other side. So I get tan square of A minus 5 is equal to 1, because 2 divided by 2 is going to be 1. I can show that step actually. So I can say tan square of a minus 5 is equal to 2 by 2, which means tan square of a minus 5 is equal to 1. And therefore I can say tan of a minus 5 is equal to square root of 1, which is 1. Now again in the trigonometric table, I am trying to find that value of angle for which the tan is equal to 1. So I remember that tan 45 is actually equal to 1, which means a minus 5 should be equal to 45 degrees, and therefore the value of angle A is therefore 50 degrees. So the answer to the second question is 50 degrees, right? So let me just note down that over here. The answer to the first one was 20 degrees. Now, one important thing that you must have noticed here is this minus 5 cannot transpose to the other side directly because it is actually the whole angle. So, a minus 5 is the whole angle under discussion, which is why it cannot transpose to the other side unless this tan goes away. So, once I had a minus 5 is 45, then the minus 5 could transpose to the other side and become plus 5, right? So this is how I solve this second question. Let us now solve the third question. We have 3 cosec square a minus 4 is equal to 0. So let's transpose the 4 to the other side. So I get 3 cosec square a is equal to 4. 3 is in multiplication with cosec square a, so it becomes cosec square a is 4 by 3. Taking square root on both sides, I get cosec a is equal to square root of 4 by 3, which means cosec a is equal to square root of 4 is 2 and square root of 3 is root 3. Now I know that cosec is the reciprocal of sine. So if cosec a is 2 by root 3, it means that sine a is equal to root 3 upon 2. And now in the trigonometric table, if I try to find that value of angle for which sine is equal to root 3 by 2, then I get angle equals 60 degrees, right? So therefore angle A is equal to 60 degrees. Let us now take a look at the next one. We have sec 2a. Sec 2a is equal to 1. And I know that sec is the reciprocal of cos. So taking reciprocal on both sides, I get cos 2a is equal to 1. Reciprocal of 1 is basically 1, right? So now cos 2a is 1. I am trying to find that particular angle whose cos is 1. So I know that cos of 0 is equal to 1, which implies that 2a should be equal to 0. 2a equals 0 implies that a should also be equal to 0. So the solution to the third one was basically 60 degrees. The solution to the fourth one is 0 degrees. Let us now go ahead and solve the fifth one. So in the fifth one I have cos of 5a minus 30 is equal to 0. I am trying to find that particular angle whose cos is equal to 0. So from the cos table or from the cos row in the trigonometric table, I remember that cos 90. So cos of 5a minus 30 should be equal to cos 90 because cos 90 was 0, and therefore 5a minus 30 should be equal to 90, which means 5a is 120 and therefore the value of a is 120 by 5, which is 24. So this is how I can calculate the value of angle A. So I will just pause for a couple of minutes so that you can take a look at all the solutions. One important activity that you should do now during the time I pause is try plugging in the answers into the variables and see if it satisfies the equation. For example, consider the first answer is 20. So this is tan square of 3 times 20. A is 20. So 3 times 20 is 60. I know that tan 60 is root 3. So square of root 3 is 3, which means that A equals 20 degrees satisfies the first equation. Let me do the second one also for you. So I have 2 tan square of, the value of A is 50. So it becomes tan square of 50 minus 5. 50 minus 5 is 45 and tan 45 is 1. So this becomes 2 tan square of 45, which is 2, and that is also going to satisfy the given equation. So try doing it for the other values of a, and you will notice that our answers are absolutely correct because they satisfy the given conditions. So pausing for a couple of minutes. Moving on to the next set of questions. Let's consider the following question. Triangle ABC is a right angle triangle at A. So we have a right angle triangle ABC whose angle A is equal to 90 degree. So let's quickly draw it. Now we have to show that sine square B plus cos square B is equal to 1 and sine square C plus cos square C is equal to 1. So let's take the first subpart. I need to find sine square B plus cos square B. So I need to find sine square B plus cos square B. What is the value of sine B? So when I say I want to find sine B, angle B is the angle under consideration. So let us quickly label it. So sine B is therefore going to be, sine B is going to be the opposite side. So the opposite side is AC divided by the hypotenuse, which is BC. And similarly, we need to find the value of cos B. So cos B is the adjacent side. So the adjacent side with respect to angle B is AB divided by the hypotenuse again, which is BC. Now I am supposed to find sine square B. So if that's the case, then sine square B can be easily found out as AC square divided by BC square. And cos square B also can be found out as AB square divided by BC square. And now I should find sine square B plus cos square B. So sine square B plus cos square B becomes AC square by BC square plus AB square by BC square, right? This is the addition of sine square B plus cos square B. And therefore the LCM is now BC square. So the LCM is BC square. And the numerator is going to be AC square plus AB square. Now, according to the Pythagoras theorem, if you write the Pythagoras theorem for this particular triangle, it is going to be AB square plus AC square is equal to BC square, right? So the hypotenuse is BC, so square of the hypotenuse is equal to sum of the squares of the other two sides. So AC square plus AB square is therefore equal to BC square upon BC square, and BC square upon BC square is equal to 1, which implies that sine square B plus cos square B is equal to 1. Now I'm again going to pause for a minute before I move to the B subpart. But what I want to explain again here is, if sine B is equal to AC by BC, when I say I'm finding sine square B basically means it is the square of sine B, and the square of AC is therefore AC square, and square of BC is BC square. So this is how I found sine square B and cos square B. Now I am also going to prove the second part in a minute's time. Okay, let us now solve the second subpart, which is sine square C plus cos square C. So now that I am going to find sine square C plus cos square C, it means that angle C is the angle of reference now. So let's take angle C now, and let's mark angle C. So I have sine square C plus cos square C. So this is angle C. So let's write the value of sine C. So sine C is going to be the opposite side. The opposite side is AB upon the hypotenuse. Hypotenuse is BC. And similarly cos C is going to be the adjacent side, which is AC, divided by the hypotenuse, which is BC. And therefore sine square C is AB square divided by BC square. And cos square C is equal to AC square divided by BC square, right? So we again squared both sides. So sine square C plus cos square C is equal to AB square by BC square plus AC square upon BC square. Now the LCM is going to be BC square, and the numerator is AB square plus AC square upon BC square. AB square plus AC square is BC square. So what I get here is, this is BC square upon BC square, and BC square upon BC square is therefore equal to 1. Hence I can say that sine square C plus cos square C is also equal to 1. To add some more information to this is actually a fundamental. This is called a fundamental trigonometric identity. This is a fundamental trigonometric identity because it is an identity because it is true no matter what the angle is. So in algebra, we know that identities are those relations which hold true for all values of those variables or those expressions. So similarly, no matter what the angle is, sine square of an angle plus cos square of the same angle is always equal to 1, and that was exhibited here in case of the first question. I had sine square B plus cos square B, and in case of the second equation I had sine square C plus cos square C equal to 1. So sine square of an angle plus cos square of the same angle is always equal to 1. We could test it out for different standard angles that we know. We will do that in a moment. And I will again pause for a minute for you to take a look at this solution. And then we will try out different angles and see if sine square of the angle plus cos square of the angle is equal to 1. Okay, let us try this identity with different angles. So I have taken all the 5 standard angles that we know. So let's find sine square 30 plus cos square 30. Sine 30 is half the whole square and cos 30 is root 3 by 2 and then there is a whole square. So half the whole square is basically 1 by 4 and root 3 square is 3 and 2 square is 4. So this becomes 4 by 4 which is actually equal to 1, right? So sine square 30 plus cos square 30 is indeed equal to 1. Let us try this same thing with angle 60. So sine 60 is root 3 by 2 the whole square and cos 60 is half again the whole square. So this becomes 3 by 4 plus 1 by 4 and 3 by 4 plus 1 by 4 is equal to 1. Let's try this with angle 45. So it is 1 by root 2 the whole square plus cos 45 is also 1 by root 2 and then there is a whole square. So this becomes half plus half and half plus half is equal to 1. Similarly, let's try with angle 90 degrees. So sine 90 is 1. So this is 1 square plus cos 90 is 0. That's 0 square and 1 square plus 0 square is 1 plus 0 which is 1. And again, let's try this with angle 0. So sine 0 is 0 and cos 0 is 1. So this becomes 0 square plus 1 square is equal to 1. You will notice that no matter what the angle is, sine square of the angle plus cos square of the angle is indeed equal to 1. Now, if you are wondering why is this happening with all angles, if you remember, we solved the earlier problem using Pythagoras Theorem, right? So we had used the Pythagoras Theorem to solve this particular question, and that is why the value of sine square plus cos square is always equal to 1. In Pythagoras Theorem also you must have noticed that squares of the sides are involved and sine square is also going to involve square of the sides, and that is why this theorem holds true for all angles. So again, moving on to the next question now. The next question is as follows. Prove that the trigonometric ratios sine and cos are such that sine is always greater than or equal to 0, less than or equal to 1, and cos is also greater than or equal to 0, less than or equal to 1 for all acute angles theta. For all acute angles theta. Okay. So let's consider this question. By the way, if the angle theta is acute, then we should be changing this question where 0 and 1 are not taken in. Okay. And I will explain the significance of this later on. So let's assume that we have a right angle triangle in which one of the angles is theta. So let's mark this particular angle as theta. Now I know that according to the definition of sine and cos, I know that sine theta is defined as the opposite side upon the hypotenuse. With respect to theta, BC is the opposite side, so it's going to be sine theta is BC divided by AC. And similarly, cos theta is defined as the adjacent side, that's AB, divided by the hypotenuse, which is AC. Now we know that the value of BC, so BC and AB are both greater than 0. So we know that BC is greater than 0. And we also know that AB is also greater than 0 because the angle is an acute angle, and acute angles are angles which are greater than 0 and less than 90. That means these sides are greater than 0. And we also know that the length BC is less than AC, as well as AB is also less than AC. So the length BC is greater than 0 and less than AC. The length AB is also greater than 0 and less than AC. So now if you think of sine theta, see sine theta is BC divided by AC. I know that out of BC and AC, AC is greater and BC is smaller, right? That means this is the ratio of a smaller quantity divided by a larger quantity, and this ratio is therefore going to be less than 1. Similarly, cos theta cos theta is also equal to AB divided by AC. Now between AB and AC, AC is greater and AB is smaller, right? So this is the ratio of smaller and larger quantity. So smaller by larger basically again is less than 1. And that's why cos and sine are both less than 1. And since their values are positive, BC and AC and AB and AC are positive, this ratio is also greater than 0. And that is why we can say that, so hence we can say that sine theta is greater than 0 and less than 1. And at the same time cos theta is also greater than 0 and less than 1. So let us quickly remind ourselves of the trigonometric table for standard angles. So this was the table for sine and cos. If you see, the value of sine increases from 0 up till 1 as the angle increases from 0 to 90, whereas cos decreases from 1 to 0 as you increase the angle from 0 to 90. But all these values are definitely between 0 and 1. So for example, root 3 is 1.732. So the value of root 3 upon 2, is 0.866. If you calculate, root 3 is roughly 1.732. So 1.732 divided by 2 is 0.866. Similarly, half is 0.5 and 1 upon root 2 is 0.707 approximately. So you will notice that all these values are between 0 and 1. Pausing for a minute for you to grasp these concepts before we move on to our next question. Moving on to the next question. So let's consider the following question. In a right angle triangle ABC, right angled at B, so angle B is equal to 90 degree. Angle C is marked as theta. So we have already marked angle C as theta. Write an expression for angle A in terms of theta. Okay, so I have to find an expression for angle A in terms of theta. That's going to be quite simple. I already know the angle sum property of a triangle. So I can say in triangle ABC, I know that angle A plus angle B plus angle C is equal to 180 degree. And the reason for this is angle sum property of a triangle. Angle sum property of a triangle. So I know that angle A plus angle B is 90 plus angle C is theta is equal to 180, which means angle 180 is 180 minus 90 minus theta, and therefore angle A is going to be 90 minus theta. So the expression for angle A is therefore 90 minus theta. Let's mark the angle. Now we have to prove the following. We have to prove that cos square A plus cos square C is equal to sin square B. So the first part is done. We have found an expression for angle A in terms of theta. It is 90 minus theta. Let's move on to the second part, which is cos square A. So that's my left hand side. Cos square A plus cos square C is equal to sine square B. Sorry, that's the RHS. So let's evaluate the RHS separately, right? So let us evaluate the RHS separately. So this is RHS, and I know that angle B is 90, so this is sine square 90, and sine 90 is 1, so that's 1 square, and therefore the RHS is equal to 1. Let us now evaluate the LHS. So we have cos A. So what is cos A? From this particular figure, let us note down cos A. When I am trying to find cos A, it is basically the adjacent side to angle A, that's AB, divided by the hypotenuse is AC. So cos A becomes AB divided by AC the whole square, plus cos C. So cos C is this particular angle, C is this angle. Cos of this angle is going to be the adjacent side, that's BC. So BC divided by the hypotenuse again, which is AC the whole square. So therefore on expansion this becomes AB square upon AC square plus BC square upon AC square, right, opening up the brackets. And now the LCM is basically AC square. So the LCM for this is AC square, and the numerator is going to be AB square plus BC square. Now think about it. What is AB square plus BC square? This is AB square plus BC square. So according to Pythagoras theorem, for this particular triangle, I can say that according to Pythagoras theorem, I know that AB square plus BC square is equal to AC square, right? The sum of the squares of the two sides is equal to the square of the hypotenuse, and that is why the numerator therefore becomes AC square divided by AC square, which is equal to 1. And therefore cos square theta plus sine square theta, or what did we have to prove? We had to prove that cos square, I can therefore say that the left hand side was cos square A plus cos square C is therefore equal to 1. Hence proved. Again, this is shown using the Pythagoras theorem. So this can also qualify as an identity, a fundamental trigonometric identity, which will always hold true no matter what the angles A and C are. As long as angle B is equal to 90, it is going to, this is going to hold true. So again, let me pause for a minute before I move on to my next question. So in this question, both the LHS and RHS were equal to 1, and hence we can conclude that cos square A plus cos square C is indeed equal to sine square B. So let me now move on to the next question. Okay, let's now move on to the next question. Show that tan theta can take any positive value between 0 and infinite or undefined for an acute angle theta. So let's consider a right angle triangle again, right? So this is the right angle triangle, Assume that this angle is theta, and let's mark the vertices. Angle B is equal to 90 degrees, which is why we are able to apply trigonometry right now. So tan theta according to this triangle is going to be tan is opposite upon adjacent. So tan is going to be AB divided by the adjacent side, which is BC. Now between AB and BC there is no fixed relation between these sides, right? For example, I can now consider three cases. So this is case 1. In this particular case I have BC is greater than AB. Now I can also have two more cases. So in the first case I had BC greater than AB. So in case 1 I had BC greater than AB. So now you will notice that tan theta in this case is going to be AB upon BC. Now BC is the greater value, right? BC is the greater value and AB is the smaller value. I know that the value of AB by BC therefore is going to be less than 1, right? So of course AB and BC are both positive, which means that the value is greater than 0. So I definitely say that in case 1 I have tan theta is greater than 0, but it is definitely less than 1. Now let's consider the case 2. So in case 2 I have an isosceles right angle triangle. So I have BC equal to AB, and therefore in this case tan theta is going to be AB upon BC again, and AB and BC are equal in this case. Therefore in case 2 tan theta is going to be equal to 1. And if I were to talk about case 3, so in case 3 I have AB is greater than BC, which means tan theta is equal to AB divided by BC. If I were to look at the different sides, then AB is the greater side and BC is the smaller side, right? So the ratio AB by BC is a greater side divided by smaller side, which is definitely going to be greater than 1. So in case 3, I have the value of tan theta to be greater than 1, and there is no limit to the value of tan theta. The value of tan theta can just keep increasing till any higher value. Therefore, from these three cases, I note that the value of tan theta, can be greater than 0. So tan theta is definitely greater than 0 and it is less than undefined. The important point that I would like to make over here is, in one of the previous problems, we had seen that sine theta and cos theta were both greater than 0 but less than 1, greater than or equal to 0 and less than or equal to 1, because at 0 and 90 the values were 0 and 1. But otherwise sine and cos always fluctuated between 0 and 1, because sine and cos both took hypotenuse into account. Tan does not take the hypotenuse into account, which is why the value of tan can even be greater than 1. Whereas sine and cos always have the hypotenuse in the denominator, which is why sine and cos cannot have values greater than 1. So this is the difference between sine and cos. I would like to pause over here for a minute, and we end our today's session over here. ending today's session over here.